Okay, today what we're doing is going back a couple of days ago. It's going to be familiar to what we did a couple of days ago. Yesterday, we looked at classifying relations. So we looked at relations that are linear and nonlinear. And in grade 9, we mostly talk about linear relations. That's really our focus. So everything, almost everything in grade 9, what we're talking about is, is linear relations. And the two most important things about linear relations are where does it start, or how much at 0, and what is the change. Now, what you'll notice that's different about today, in the past, we started with the table and we used the table to come up with the rule. And then we were also using the rule and the table to make the graph. But in this case, we're given the rule. Okay. And you'll notice that the letters are different. I said this before. So before it might have been T equals, so the frame number or the number of blocks, whatever it is, the term number, T equals 2 times, T is the total number of blocks, is equal to 2 times the frame number plus 1. Okay, that would be like the rule in this case. But instead of using T and N, we're using Y and X. Um, and so this is a big part of what we do in grade 9, especially the first part of this linear relation stuff that we're doing, is learning how to start with any one of these forms and be able to come up with the other ones. So we've already started with the table, and from the table we've learned how to make the rule, and from the table and from the rule we've learned how to make the graph. Well, now we're starting with the rule and trying to figure out how to come up with the table and the graph. So if I start with any one of these things, I want to be able to come up with the other ones as well. Now there's two ways that you can do this, and I'm going to show you a little bit of both. You can pick which one you like best. If you understand both of them, that's fantastic. If you like one better than the other, that's great. Um, what you really want to do is come up with a strategy that works for you. Some strategies are going to work a little bit better in some situations than others. So eventually we want to be able to use all the strategies and we can pick the right one at the right time. But for now, we're taking things slowly, and whatever strategy you like best, that's the one that you can go with to complete the practice. Just keep in mind that eventually you're going to see the other strategy over and over again, because we're going to keep using all the strategies and hopefully everybody will become comfortable with all of them. So I'm still going to think about this as those two most important parts of linear relation. Where does it start and what's the change? And in fact, that's kind of the key to using the rule, is examining it and deciding which part of that rule is where it starts, or how much for 0, and which part of the rule is the change. So this is the start, is always the number that's by itself. It's not multiplied by anything. It's just sitting by itself. Okay, that's always the start. And the number that's multiplied by a variable, so 2x or 2n or whatever the variable is, that's your change. So if I want to start filling out the table, the start is how much for 0. So that's 1. Then my change is 2, so that's up 2. So if I start at 1 and I go up 2, I'm at 3. Up 2 more, I'm at 5. Up 2 more, I'm at 7. Up 2 more, I'm at 9. And that's how I could use that rule to come up with those table values. Now I left myself some space in the table so that I can show the other way that we do these, that we can do these. And I'm going to skip 0 for now, and I'm going to start at 1. And 1 is my x, as you can see, because it's in the x column, which means to find y, I substitute the x value in for x in my equation. Okay, so I take that 1 and I sub it in right there. And that gives me 2 times 1 is 2, and 2 plus, so that's, this part here is 2. 2 plus 1 gives me my 3. So I used the pattern to come up with 3, and that's a great way of doing it because it really shows your understanding of linear relations and the two important ideas of where does it start and what is the change. But then I also use this substitution that we did at the very beginning of the course, where I could take any x value and I could sub it in, and I could get the total amount directly. I'm going to do one more here. What if I wanted to sub the 3 in? What if I wanted to jump to the 3? Because when I'm doing the pattern, I have to do every row. But if I use this other strategy, I can go straight to any row I want. So again, it's going to be 2 times something plus 1, where this something is going to be 3 because I'm taking that and putting it into those brackets. 2 times 3 is 6, and 6 plus 1 is the 7 that I got there. Okay, so those are the two strategies. One of them is where does it start and what is the change, and you can get every row that way. The other strategy is subbing the value in, the x value, in for x, and doing some BEDMAS, some substitution in BEDMAS to get your answer. Okay, and then graphing it's going to be the same. I can use either strategy we used before. I can use where does it start? Well, it starts at 1 and goes up by 2, so up 2, up 2, up 2, up 2. Or I could think of these as pairs and plot them. So 4, 9 would be 4, 9, and that would give me this point here. And then again, whenever we're done this, we connect the points with a line because that shows the pattern, and my line goes all the way up past the edge of the graph. Okay, what about this one? We're just going to look at a few more examples of this. What about this one? Well, this one looks like it's missing something, and some people start to get confused here. In fact, the last, I'll go back up to this one. We often wrote these as t equals 1 plus 2n. So we had the start as the first number and the change as the second number. But the order of the numbers is not what's important. We saw when we talked about it here that the change is which one is with the x, and the start is the number that has no x with it. So when I come down here, this is 4 times x, which means 4 is the change. So what does that mean the start is? And if we look back at some of the other examples that we did, we would know that the start, this is like 4x plus 0. So my start is 0, and I couldn't actually see it because this was all covered. None of this was here, and it just looked like that. But now I can see it. And I kind of messed that up while I was doing that, but that's okay. There we go. So where does it start? Where it starts is how much for 0? I've got 0. What am I going up by? I'm going up by 4. So from 0 up 4 is 4. From 0 up 4 more is 8. From 0 up 4 more is 12. I'm adding 4 every time. For the last one, we already kind of know what the answer is going to be, but I'm going to use the other strategy. So y equals 4x, so I've got 4 times x, but I use empty brackets for x, and I take this value and I put it in there, and it becomes 4. And 4 times 4, this is where I'm just going to use my calculator. Make it a bit bigger so we can really see it. And I'm going to do 4 times 4. And that allows me to get the answer directly. Okay. And this one's doesn't have label for some reason, so this is a good reminder that we always want to label 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 10. 1, 2, 3, 4, 5. I like to label every 5 just because it's way faster. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then labeling every one, it's not as cluttered, it's nice and clean, and it's faster, it's easier because it's less writing. So we started at 0, And every time we went over 1, we went up 4. And there we have it. There's that pattern. Okay, looks like we only have one more. And this is another one that's a little bit trickier. And what we need to look at is that there's two parts. Where does it start? And what is the change? Remember I said the start is the number that's all by itself. Well, what number here is all by itself? 16. So this is the start. Which means what is the change? And some of you might have noticed, you might have already sort of observed this, that there's a minus sign here instead of a plus sign. So I'm starting at 16, and every time I'm subtracting from that. So that means I'm going down. So my change is going to be down. And how much? 1, because this is like 1x. If it was 2x or 3x or 4x, so minus 2x minus 3x minus 4x, I'd be going down 2, down 3, or down 4. But in this case, it's just minus x, which means minus 1x. So I'm going down 1 every time. Okay, so I can fill out my chart here, and I've got 16, sorry, I'm starting at 16, so here's my 16. Then I'm going down 1, or 16 subtract x. X is 1, 16 minus 1, or down 1 is 15. Down 1 more is 14. I'm going to do the same thing I did last time and use my other strategy. 16 minus x. Take 4 and put it in there. 16 minus 4 is 12. And if I follow this pattern, 16, 15, 14, 13, 12, if I follow that pattern, I would get the same thing. Okay, let's graph this one. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oops, 20. 1, 2, 3, 4, 5. I like to make sure that my scale goes past the biggest number. So that's why I went to 20, because 16 was the biggest number. So I'm starting at 16 and I'm going down 1 every time I go over 1. Okay, and there you have it. There's that one. So from the rule, I can come up with the table. From the rule and the table, I can come up with the graph. These are 3 of the ways. There's actually 4 ways that we're going to look at. And these are 3 of them. We're not going to introduce the 4 for a little bit, but these are 3 of them. And what we're learning is how to go from any one of them and switch over to the other 2. And we always have it coming down to where does it start and what is the change.